Number 10. Reading weather by clouds. Your weather app relies on supercomputers and satellite data, yet it still gets the weekend forecast wrong. Meanwhile, people a century ago could look at the sky and know exactly what was coming days in advance. Clouds are the atmosphere's early warning system. Those high, thin, wispy clouds that look like brush strokes are called cirrus clouds. Old sailors called them mare's tails. They mean rain is coming within 24 to 48 hours. Soon after, the sky might get a milky, hazy look. If you see a glowing halo around the sun or moon shining through that haze, rain is almost certainly hitting within 12 hours. Then there's the cumulonimbus. It starts as a fluffy, innocent-looking cloud, but grows vertically at massive speeds. By evening, the top flattens out into an anvil shape. That anvil is assigned to seek shelter immediately. It's a thunderstorm factory with updrafts strong enough to hold airplanes in place. If the base of the storm starts to twist like someone is stirring the sky with a giant spoon, you are looking at a supercell capable of dropping a tornado. Nature constantly broadcasts the exact weather conditions. We just stopped paying attention. Number 9. Hand drafting. Before AutoCAD or Revit existed, every building you've ever walked into was drawn by hand, with a T-square, a set of triangles, and a mechanical pencil, and the person drawing it had to get it right, because there was no undo button. When software crashes right before a deadline, suddenly everyone is looking around because nobody knows how to put a clean line on paper. The person who can instantly becomes the most valuable person in that room. Architects call it thinking through the pencil. When you draft by hand, you have to plan every line before you make it. You have to understand the three-dimensional geometry before you translate it to 2D. Software lets you figure it out as you go, which usually means the software does the thinking for you. Studies on architecture students show that those trained in hand drafting first produce more spatially accurate digital models later. Hand drafting also teaches line weight. A thick line, a dashed line, or a center line all mean completely different things on a technical drawing. Modern designers just click a layer and move on. The person who learned to draft by hand knows exactly why those rules exist. Right now, firms actively fight over graduates from the few remaining programs that still teach this. Number 8. Slide rules. Before calculators became pocket-sized, engineers did complex math using a wooden stick covered in sliding parts and numbering scales. It's called a slide rule, and NASA engineers famously used them to send Apollo 11 to the moon. Instead of directly adding numbers, a slide rule adds lengths. Because of how logarithms work, adding these specific lengths is the equivalent of multiplying or dividing numbers. You slide one piece against another, line up the tick marks, and boom, you have your answer. During World War II, artillery crews in active combat zones used slide rules to calculate firing angles in seconds. A trained user can multiply obscure decimals faster than the average person can unlock their smartphone. Plus, a slide rule never runs out of battery, never requires a software update, and still works perfectly when the power grid fails. But the most valuable part is what it teaches your brain. A slide rule doesn't tell you where the decimal point goes. You have to estimate the rough size of the answer before you calculate it. Modern calculators just hand you a number, but a slide rule forces you to truly understand the math. Number 7. Historic plastering. Most modern walls are made of drywall, essentially compressed chalk sandwiched between paper. But old houses were built with real plaster, a 3-coat system mixed from lime, sand, and actual animal hair, usually from horses or goats, to bind it all together. When old plaster cracks, you can't just slap modern joint compound on it. The wall will reject it like a bad organ transplant. Old plaster breathes and constantly moves with temperature and humidity. Drywall compound doesn't flex, so it just cracks again in 6 months, leaving you completely frustrated. The real fix requires matching the original lime-based mix in 3 distinct coats: the scratch coat, the brown coat, and the finish coat. Each layer does a specific job, and each has to cure perfectly before the next goes on. This is why historic preservation societies are running emergency training programs to keep this skill alive. A master plasterer can charge a serious premium because there are only a handful left in any given city. If you know how to wield a trowel, manage cure times, and mix goat hair into wet lime, you have an increasingly rare, highly lucrative trade. Number 6. Animal tracking. A search and rescue team is looking for a missing hiker. They've got drones, GPS, and radios, and they are completely lost. Then someone calls in a tracker, one guy with no gadgets. Within an hour, they find the hiker. Animal tracking is one of the oldest human skills, but almost nobody knows how to do it anymore. A real tracker can look at a footprint and tell you the animal, its weight by how deep the print sank, and its speed by the distance between tracks. Fresh tracks have sharp, crisp edges. Old tracks crumble and dry out, but footprints are just the beginning. Broken twigs reveal movement direction. Fur caught on bark indicates passing height. Disturbed leaves show exactly where something stopped to rest. There's also a phenomenon called a pressure release. When an animal steps down and pushes off, the soil moves in a highly specific way. A master tracker reads that movement to determine if the animal was relaxed, injured, or running scared. Search and rescue teams are now paying serious money to learn this skill. Drones can't see under thick tree cover, and GPS drops in deep canyons, but a bent blade of grass is incredibly reliable. Number 5. Blacksmithing. Heating metal and hitting it with a hammer. That's the entire foundation of the skill, yet it took civilization 3 millennia to perfect it, and we somehow managed to forget most of it the minute factories took over. At its peak, every town had a blacksmith making tools, nails, and architectural hardware. Today, the few traditional forge schools in the country have waiting lists that are years long. Custom hand-forged ironwork has explosive demand, and a master smith can charge upwards of $500 for a single functional knife. The true skill isn't just brute force, it's reading the fire and the steel. Bright orange means the metal is soft enough to work. Dark red means your window is closing. You don't hit the metal as hard as you can, you hit it smart. The angle, force, and placement of every hammer strike determines whether you're gracefully moving the metal or just making loud noises. You also have to manage the forge itself. If a fire gets out of control, you will literally burn the steel, causing it to crumble and emit an atrocious smell. Blacksmithing turns fire and raw minerals into incredible functional art, and people are finally remembering exactly how valuable that is. Number 4. Ice preservation. Before refrigerators plugged into walls, there was an entire global industry built around keeping things cold. It worked so well that ice was harvested in Boston and successfully shipped across the ocean to India in the 1800s. The merchant behind this, Frederick Tudor, was called crazy until he figured out the secret: sawdust. Thick layers of sawdust packed around the ice acted like a massive thermal blanket. Because wood is a terrible conductor of heat, the ice barely melted during a months-long voyage. The underlying skill here is understanding thermal mass. Cold things stay cold longer when surrounded by other cold things. A full freezer survives a modern power outage almost twice as long as an empty one. If you wrap a block of ice in layers of crumpled newspaper and stuff it inside a wooden box, it stays frozen far longer than you'd expect. People used to harvest ice in winter and store it underground in sawdust-lined pits where temperatures hovered around 50 degrees year-round. It's not glamorous, but understanding these basic principles keeps insulin cold, prevents baby formula from spoiling, and saves food during a multi-day blackout. Number 3. Reading meets and bounds surveys. There's a document sitting in a courthouse right now that describes a property boundary like this: beginning at an iron pin, thence north 47 degrees 32 minutes east, to a stone marked with 3 notches, thence south to a white oak tree. This is called meets and bounds surveying. It's how land was described for hundreds of years before GPS, and most of those old descriptions are still the binding legal record. People are showing up in court with these old documents and winning land disputes worth hundreds of thousands of dollars just because they can actually read the surveys. The landmarks themselves can be wild. A common one is the large chestnut tree near the road, except chestnut trees were almost completely wiped out by a blight in the early 1900s. You have a legal document pointing to a tree that hasn't existed for a century, and somebody has to figure out exactly where it was. The angles in these surveys are written in degrees, minutes, and seconds. Once you understand the underlying system, you can manually walk a property line drawn up in the 1800s. Real estate attorneys and title companies are actively looking for people who can translate this forgotten language. Number 2. Cooperage. Every drop of bourbon you've ever tasted spent years sitting inside a hand-built wooden barrel, not a metal tank. A barrel made by a craftsman called a cooper, using skills passed down for centuries. Right now, the entire global whiskey industry runs exclusively on these barrels, and the number of people who know how to make them is shrinking rapidly. A barrel doesn't just hold the liquid, it creates the flavor. When bourbon sits in a white oak barrel, the wood breathes. It expands in the summer heat and contracts in the winter, pushing the liquid in and out of the wood. That's where you get those rich notes of vanilla and caramel. A cooper builds a barrel without a single nail or drop of glue. They take around 30 precise wooden staves and stand them in a circle. They heat the wood over an open fire to make it flexible, then slowly winch the bottom together until the staves lock entirely through pure tension. Because American law dictates that bourbon must be aged in brand new charred oak barrels every single time, distilleries need millions of them a year. Master coopers are so rare that major distilleries are constantly running internal apprenticeship programs just to keep the art alive. Number 1. Reading analog gauges. If a modern industrial facility loses its digital monitoring systems to a software crash or power failure, alarms trigger and panic ensues. But the old analog pressure gauges bolted to the wall from 1987 will still be sitting there, pointing at exactly the right number. Analog instruments don't need Wi-Fi, updates, or batteries. A pressure gauge is just a coiled piece of metal that bends precisely when pressure changes. Just pure physics doing its job. But reading them quickly under pressure is a dying art. A digital display just hands you a number. An analog gauge forces you to interpolate, figuring out exactly where that needle sits between 2 marks. Experienced operators read these in under a second and keep moving. That gap in processing speed is the difference between an easy catch and an industrial disaster. It's the same with analog depth gauges on submarines. Salt water and extreme pressure destroy circuit boards, which is why physical backups are mandatory. When the digital layer eventually fails, the person who can walk up to a wall of physical needles and understand exactly what's happening instantly becomes the most vital person in the room.